It's noontime. Welcome to today's Learn at Lunch featuring Dr. Astrid Caldas, who is Senior Climate Scientist with the Union of Concerned Scientists. My name is Hanson Robbins, and I am Chair of the Special Events Committee and responsible for arranging Learn at Lunch events. Climate change is a subject of concern to some and confusion to others. Luckily, with Zoom technology today, we can see and hear what an expert has to say. You are currently muted when you signed on. The mute symbol is on the bottom or side edge of your screen. You may unmute yourselves after Astrid has finished her talk at a Q&A session. If you have a question, please use the chat symbol at the bottom of your screen. Simply open it and enter an asterisk. All you have to do is one asterisk. This will put you in line to ask your question directly to Dr. Caldas. I have asked Jan Elvin, a friend of Astrid, to introduce her. So without further ado, I turn the mic over to you, Jan, to introduce Astrid.
Thanks, Hanson. I'm Jan Elvin. I'm the chair of WCAll, and I'm very excited today to be able to introduce my old biking pal, Astrid Caldas. When I lived in DC, we used to bike together with a group called Babes on Bikes, okay? This is true. And anyway, Astrid is just superbly qualified to talk to us on this subject. As Hanson said, she's a senior climate scientist with the Union of Concerned Scientists. She has a Ph.D. in ecology from the Universidade Estadual de Campinas and an MS in entomology from the Universidade Federal do Paraná in Brazil, and also a master's in environmental management from the University of Maryland. She's going to talk about the current state of the global climate, explain some global warming and climate change issues, what the stakes are, what a difference 1 degree can make, and what needs to be done to avoid these worst impacts, and also what we can do on our own home turf. I have to say one other thing about Astrid is when we were biking friends, there was a car that just about ran over me, and Astrid was behind me on her bike, and she yelled really loudly to warn me. And if she hadn't, I probably would have been hit. So I credit Astrid with saving my life. So thank you, Astrid. And she and her husband, she's very familiar with the Eastern Shore. She and her husband have come out here to Chestertown quite a bit, and they are looking for a house here, which is very exciting news. So without further ado, I think we'll let Astrid talk and take it away, Astrid. Oh, and just another reminder, make sure please that you're all muted, and when I'll call on you when it's your turn to ask a question. Okay.
Now Hanson is going to share his screen with my slides. In the meantime, thank you, everybody. Thanks, Jan. Thanks, Hanson. This is so great to be here. I speak to a lot of different audiences, a lot of different groups and different people. And this type of presentation of event is really one of my favorites because I love talking to people. So I'm not going to be talking for a long time. I don't like talking too much. I don't like listening to my voice for too long. I'd much rather hear what you have to say. Sometimes what I say is not what you're really interested in. So I'm going to give an introduction to the subject, a kind of a general introduction and some specific points, issues to Chestertown and the Eastern Shore. And then it's the fun part of it, it's the questions and what you're really interested in that I may not have mentioned. So this is how it's going to play. So The Union of Concerned Scientists is a national organization that puts science into action to build a healthier planet and a safer world. UCS, as we call it, conducts rigorous technical analysis, uses it to advocate for change, inform decision makers, shaping public opinion, creating policies to help solve some of today's most pressing problems. We have over 500,000 members nationwide. Next slide, please, Hanson. Okay, let's get this out of the way. Yes, climate change, global warming, it's happening now. Next. Yes, it is us. Next. We do have a choice. And next, scientists agree on 1, 2, and 3 that I just mentioned. Next. So, however, carbon dioxide, CO2 levels keep going up in the atmosphere. The primary cause of global warming is human activity that releases this greenhouse gas, carbon dioxide, into the atmosphere. Most significantly, the burning of fossil fuels to drive cars, generate electricity, and operate our homes and businesses. Tropical deforestation, also by human hands, is another major contributor. When these forests are burned, they release huge amounts of carbon into the atmosphere. And in addition, because the forests no longer exist, they are no longer available to absorb and hold carbon dioxide, carbon in their trunks and their leaves and everything. So this graph shows very steep going up line, and that's the concentration of carbon dioxide in our atmosphere. And you can see from 1958 to 2015, it has gone up quite a bit, and past 2015 where we are now. When carbon dioxide like this and other heat trapping emissions are released into the air, they act like a blanket. They hold heat in the atmosphere, warming our planet. And the concentration of this gas, carbon dioxide, in the Earth's atmosphere has increased dramatically over the last 150 years. Next slide, please. In fact, measurements from ancient ice cores, and I can tell more about that if you want to know how we get gas measurements from ice cores. Those measurements show that CO2, carbon dioxide, is now at its highest levels in over 800,000 years. And this graph shows from 800,000 years back all the way to present day. And you can see a big spike at the end there from the start of the Industrial Revolution and how those levels are going up. Next slide, please. Now, when we add temperature over the carbon dioxide chart, you can see that they are strikingly similar. Here we have one of them is the carbon dioxide, and the other one is the temperature. And I think the blue one is temperature. I don't remember, but it doesn't matter because I forgot to put the legend. But what matters is temperature follows concentrations of carbon dioxide in the atmosphere. Carbon dioxide goes up, temperature tends to go up. Carbon dioxide goes down, temperature tends to go down. Next slide. As the concentration of carbon dioxide and other heat-trapping gases in the atmosphere rises, the Earth warms up. And this graph shows us just the temperature change from 1880 all the way to now 2020, 2021. And you can see that it has ups and downs, of course, but the general trend that you see is a trend going up. In fact, Earth has recently undergone unprecedented warming, particularly since the 1950s. As you can see there is that the steeper line starts around 1950. Every single year since 1977 has been warmer than the 20th century temperature average. And 19 of the 20 warmest years have occurred since 2001. Globally, 2020 was the second hottest year on record, or the hottest year on record, tying up with 2016. Depending on the way they measure, NASA and NOAA, the National Oceanic and Atmospheric Administration, and NASA that everybody knows, the Aeronautics Agency, they measure it a little bit differently, but no matter, 2020 and 2016 were the hottest years so far. Next slide, please. So yeah, you can see there, this little graph with a little, some events showing in the figure. Carbon dioxide levels keep going up But guess what? Scientists can tell the difference between carbon dioxide from natural sources and from human sources. And that's a very important point. Next slide, please. We know that warming and cooling have happened in the past, long before humans were around. Those are natural climate drivers, as we call them, energy from the sun, aerosols. And aerosol is not the spray that we use. Aerosols are tiny particles that are suspended in the air. They are called aerosols. Aerosols from volcanic eruptions, from dust, from salt spray, all these are called aerosols, and they tend to kind of cool the atmosphere. There has been several volcanic eruptions in the past that led to a decrease of 1 to 2 degrees centigrade in temperature throughout the earth because of those aerosols. So it has always been gone up and down, and we know that. All of these factors have really shaped the Earth's climate. However, none of them sufficiently explain the recent dramatic increase in global temperature. For that, scientists need to include human activities. And we know human activities are driving the increase in carbon dioxide concentrations because atmospheric carbon dioxide has information about its source. So each molecule of carbon dioxide in the atmosphere, we can tell where it came from. We can tease apart how much carbon dioxide comes from natural sources, some of those I mentioned, and how much comes from the burning of coal, oil, and gas, the fossil fuels. So if you look at this graph that's a little low resolution, you can see that the blue line is models for past temperatures using only what we call natural forcings, those natural drivers that I mentioned before. The pink line is the one, the model that shows the temperature we're using both the natural and the human anthropogenic forcings. And the black line, that is the actual observations since 1850, actually accompanies the pink line. So that's how we know that if we remove the emissions that are caused by human burning of fossil fuels, the actual observations do not follow the temperature increases that we are seeing. So that's how we know for sure from data, from observation, that humans are the ones that are really causing this increase of temperature in the atmosphere. Next slide. And save your questions, write them down, because at the end, if anything you don't understand, anything you want clarification, you know, that's the fun part, as I mentioned. So I mentioned global warming and climate change separately up to now. Climate change and global warming are not the same thing. Global warming is just that, warming. That warming has already brought changes in our climate. And as this slide says, these changes will likely include, in the future, will likely include major shifts in wind patterns, annual precipitation, seasonal temperature variations. These are the things that make our climate. So global warming is just warming. Next slide, please. Right now, we are seeing many signs of climate change that is caused by the global warming. Those include the melting of glaciers, changes in snowfall and cover, sea level rise. Recently, we have observed changes in ocean circulation patterns. It's been all over the news because those big circulations on the Atlantic are what allow certain areas of the Americas and Europe to actually have civilization and to be warm enough for us to live there. If those patterns change, our climate can completely change. And all these things, these climate changes, we don't know exactly how they are supposed to change because there is a lot of interactions, but they are expected to intensify if we don't really do something to prevent the worst of climate change and those impacts. Next slide, please. So it's important to note that even if the emissions stopped completely today, we would still be committed to a certain amount of warming because of past emissions that are still lingering in the atmosphere. Carbon dioxide tends to stay for about 100 years in the atmosphere. So all that carbon dioxide and other gases that increase warming in the atmosphere, such as methane and others, they are there. So even if we stopped emitting, they are still there. If we don't take them out of there, we're still going to see warming. So we have to plan for the global warming and the consequent climate change that we cannot avoid. So here I'm going to tell you a little bit about where we are and what we need to do to avoid that worst part of climate change. Next slide, please. So in 2015, leaders around the world came together for the Paris Climate Agreement. Everybody here probably has heard of the Paris Agreement, right? Why is the Paris Agreement important? Because its main goal was to hold the increase in global average temperature to well below 2 degrees centigrade, which is about 3.C Fahrenheit, and to pursue efforts to limit the temperature increase to 1.5 degrees centigrade, which is about 2.7 degrees Fahrenheit. And that is to avoid the worst of impacts of climate change. After that, the United Nations, which hosted the Paris Agreement, asked scientists to issue a special report on the state of the climate globally and the difference between warming of 1.5 and 2 degrees centigrade. That report aimed to answer questions. What are the impacts of climate change at 1.5 warming and at 2 degrees warming? And what would it take to limit warming to those levels? And what would be the implications for sustainable development and equity considerations of those degrees of warming? Next slide, please. So on the left, you see here that the global warming of 1.5 degrees is the name of that report. It came out late in 2018. And another report, the National Climate Assessment, specifically for the United States, came out soon after that. And the findings of both those reports were really sobering and very similar. Next slide, please. We're currently in a 1 degree Celsius world. We have warmed 1 degree Celsius, actually a little more by now. And that's above pre-industrial times, 1850s. Next slide, please. We're all feeling the impacts, right? Hurricanes are becoming more powerful and deadly because of rising ocean temperatures, because ocean temperatures, the warmer they are, they feed the hurricanes, they make hurricanes stronger. Sea level is rising because warm water also expands and takes more space, not to mention ice that's melting in the ocean. In California, we saw a lot of the wildfires. Wildfire season is not only increasing in length, but it's increasing in extent. Areas being burned are much bigger. We are also seeing more intense rainfall. Hello, Ellicott City, and associated floods. And the Arctic is warming really fast. The Arctic has warmed a lot more than the rest of the globe. It has warmed up to 8 degrees already. So that the consequences of a warming Arctic doesn't stay in the Arctic, as we always say. What happens in the Arctic does not stay in the Arctic because that influences global climate. So the implications of all that, are that people are really paying the price. And we see not only the direct impacts, but the inequities for people who are on the front line of these events. The people who have the least resources are being hit first and worst by these impacts. Next slide. So at the current rate, we would reach 1.5 degrees centigrade between roughly 2030 and 2050, depending on the future emissions. But the report also found that the emissions, those that are already out there, they are not enough to warm us 1.5 degrees. So that means to get to 1.5 degrees, we have to keep pumping carbon dioxide in the atmosphere. So that means that if we stop pumping, we have a chance of really not warming that much, right? If we stopped all emissions, what's out there is not going to warm us 1.5. So, we have a shot at not reaching 1.5 or 2 degrees. It's a long shot because it entails reducing emissions drastically, but it can be done with willpower and a lot of changes. Next slide. The report also highlighted striking differences between 1.5 and 2 degree warming world. Next slide, please. Every half a degree of global temperature rise creates consequences for millions of people and for ecosystems around the world. This is a very busy slide, I know, but I want you to look at the colors. Already in our 1 degree Celsius world, that's the thick line right there in the middle, that's 1 degree warming where we are right now. Warm water corals, for instance, are at moderate to severe risks. They are the ones on the far left. That's the warm water corals. So you can see that they are already on the pink and red, colors. They're not green at all. Small scale, low latitude fisheries, the Arctic, coastal flooding, they are all at moderate risk. So others are low to moderate risk, others are at low risk, the greens are low risk. But if you look at 1.5, the 2 degrees, the two skinny lines above the fat 1 degree line, you see how those bars get more and more into the orange, red, and yellow. So that means that they are going to be at risk. They are going to be endangered. All those systems and processes and everything that we depend upon is going to be at risk. And this is what we're trying to avoid. We're trying to avoid getting into those reds and yellows and everything. Next slide, please. So the second report is the National Climate Assessment. It's equally sobering, if not more so, because it focuses here on the United States, and it's directly related to us and the changes that lie ahead right here if we don't do anything. The National Climate Assessment is a report mandated by Congress, and it's to be released at least every 4 years, and evaluating the state of the climate in the country. Next slide, please. The findings of the National Climate Assessment. Next slide, please. That assessment found that Earth's climate is now changing faster than at any point in modern civilization, that these changes are primarily the result of human activities, the evidence of which is overwhelming and continues to strengthen and grow, and that the impacts of climate change are already being felt across the country, and climate-related threats to Americans' physical, social, and economic well-being are rising. So I put that in caps in red because it's really kind of yelling to the world. This is the main message we need to pass along. Climate change is not a distant threat. It's happening right now, and the impacts we're seeing will only get worse if we don't do something. We don't know how worse they will get, and that's tricky, but it's very, 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 very likely to get much worse. Next slide, please. Earth's climate will continue to change over the century and beyond. After mid-century, that's an important point. After mid-century, how much the climate will change and how much warming will happen will depend primarily on global emissions of greenhouse gases that we do now up to mid-century. So in the next slides, you see a couple of examples what this means. How the second half of the century is going to be different depending on how much emissions we release in the atmosphere right now. Next slide, please. For instance, depending on future emissions, the differences in projections can be very striking. This slide shows the differences in temperature projections between a world with less emissions, which are on the left. Lower scenario is fewer emissions in the atmosphere. And on the right-hand side, the higher scenario is with higher levels of emissions into the atmosphere. And you can see the difference. By mid-century, on the left, the top two maps, the one on the left is with fewer emissions, the one on the right is with more emissions. You can see there is not a lot of difference between them. There is some difference in the colors. The darker the color, the bigger the change in temperature to a warmer temperature, right? But if you look at the late 21st century, the two maps at the bottom, that's the second half of the century, the difference between the two maps is much more striking because the left one with the fewer emissions, the lower scenario, has a lot less warming than the one on the right, where you see a lot of those dark reds that have an increase of 7 and 8 degrees Fahrenheit in temperature. So that's what I'm talking about. The difference between the projections for increasing temperature and consequent climate change are very, very different depending on the amount of emissions that we release in the atmosphere. Next slide, please. And this is something that's in the heart of all of us, is sea level rise. And the map on the top is with lower scenario, fewer emissions into the atmosphere. And the bottom map is higher scenario, the one with more emissions into the atmosphere. And you can see, just look at the mid-Atlantic there on the right-hand side. Look at the difference in color. Look at the difference in sea level rise. Those are in feet. The yellows are 1, 2, 3 orange. The reds are 6 feet of sea level rise projected by the second half of the century. So if we emit a lot, we are looking at a lot more sea level rise than we would if we emitted less. So these are the things that we discuss, you know, that we look at, that we project, that we evaluate, that we research, and how to prepare for those things also. Next slide, please. So what needs to be done, and that's to be done globally, right? To limit warming to 1.5, global carbon dioxide emissions must decline by 40 to 60% by 2030. That's very near future. And reach net zero by 2050. Net zero is what you pump in, you take out by whatever means. And many scientists and many researchers and many governments assume that we're going to have to find a way to actually remove carbon dioxide from the atmosphere in order to reach that net zero by 2050. And what that will require, it would require rapid and far-reaching transitions in energy, land, urban and infrastructure, industrial systems at an unprecedented scale. And I hate this word unprecedented because I heard that so much last year. Everything goes unprecedented. But anyway, it is an unprecedented scale. It would also require deep behavioral changes around the world, how we eat, how we live, how we move about, how we lead our lives. And experts all over the world say, this is going to be the hardest hurdle because people resist change. A lot of people do not want to change. They don't want to change from the way they live. But the point is, we don't need to change the way we live. We need to find better ways to do what we do, to live with what we have, the comforts we have, everything that we have. There are better ways of doing it. And that's the transition that we need to make. Next slide, please. Okay, now let's look at sea level rise, shall we? We're getting there. I've been talking for a little bit, but you know, we'll get there soon. Excuse me. So when we think about global warming, we think about the atmosphere, right? We think about the air. The air is warming. It's getting hotter there. So hot in here. But a lot of the heat that we've been adding to the planet, to the atmosphere, has been taken up by the oceans. The overwhelmingly amount, 93% of all that extra energy and heat has been absorbed by the oceans. And as I mentioned before, warmer water takes up more space. The ocean is here. The land is by its side. It expands. The land is right here. It has nowhere to go but up. So that's sea level rise for you, right? Next slide, please. And we have already seen in a different graph where we had the curves one on top of the other. Here they are separated. We saw that temperatures follow the, carbon dioxide concentrations pretty closely. The top there is the temperature, and the middle one in green is the carbon dioxide concentration. And you see that they're very similar, right? Because of that follow thing of the temperature. More carbon dioxide, higher temperature. Lower carbon dioxide, lower temperature. But look at the sea level now. Sea level kind of follows more or less the same pattern. That's because of oceans absorbing carbon dioxide and the temperature acting in their expansion and all that thing. So you can see that there is this correlation between all these things that we're seeing, and they all start with the concentration of carbon dioxide in the atmosphere. Next slide. So this is global sea level rise since 1880. You see the line is going up pretty steep, pretty good, pretty clear. We know that sea level is rising because we have been measuring it. It has been over 8 inches globally, but locally we know that some places have seen a foot, other places have seen, 2 inches, but globally the average is 8 inches. And we measure it with tide gauges, satellite data, and along the east coast of the United States, it's much more than 8 inches as a general rule. The concerning piece is also that the rate of sea level rise is accelerating, meaning in the past 20 years, it has been going up faster than it has in the previous years. In fact, 50% of that sea level rise has happened in the past 20 years. So if you think about, you know, since 1880, we have 130 years there that have gone by. Yeah, right, 130. Anyway, the last 20 years have 60% of all that sea level rise. So things are moving faster. Things are moving faster. Next slide, please. So I'm putting a lot of charts there because some people love charts, some people hate them. But I think all these charts kind of give an idea of, you know, you see things going up, you see they are increasing, right? So that's the main point. And this chart shows the National Oceanic and Atmospheric Administration, NOAA, scenarios of sea level rise for this century. And the major difference between them, the green, the yellow, the pink, and that skinny black line on top, the main difference is ice melt. That's what these graphs differ mostly. You see that there is no scenario. You know, the low scenario is low emissions, the green one. The intermediate scenario is the yellow one, is intermediate amount of emissions released in the atmosphere. The high scenario is a lot. We continue business as usual, pumping carbon dioxide and greenhouse gases in the atmosphere. And the extreme scenario is the one that entails a collapse of the ice shelves in the Arctic and Antarctic. So you see, there is no scenario, or there is no sea level rise, right? Sea level is going to rise, period. That there's no way around it. It's going to happen. So as I mentioned before, we have to prepare, you know, because sea level could easily rise 4 feet this century, 4 more feet from what we're seeing right now. So this poses big problems because, you know, we know, particularly for coastal cities, this is a big problem. Next slide, please. And the main problem is the tides, right? Tides are one of the most reliable phenomena in the world. The sun rises in the east and the stars come out at night. We're confident that the ocean waters will regularly rise and fall along our shores. Doesn't matter. Every day they will come, twice a day here on the East Coast. So next slide, please. High tides are having a greater impact on U.S. coastal communities than in decades past for 2 main reasons. First, our shores are more heavily developed. There's a lot more people living on coastal communities and coastal cities and everything. And second, because the tides that have not changed, they are astronomical tides. They depend on planets and attraction and gravity and stuff. But those tides that have not increased or decreased, they are now occurring on top of elevated sea levels. If you have a 1 foot tide and the base level is higher, it's going to be higher, right? And that's why we're seeing a lot more floods today in a lot of coastal areas along the United States and the world. Next slide, please. The risk for coastal communities is increasing due to many factors. Climate is adding to those risks. Climate is a risk and threat multiplier. Climate by itself, climate change, global warming has, you know, some risks, but one of the main things is how it interacts with other risks, creating situations that are very hard for us to manage. Next slide, please. And this is going to go fast now. So we at UCS have been studying sea level rise, coastal inundation for a number of years now, and our last 2 reports, which is the one in the center there, when rising seas hit home, and the one on the right, underwater. They give us a glimpse of what's in store for areas that are most vulnerable to sea level rise inundation along our coasts. Next slide, please. So these reports define chronic inundation. What's chronic inundation? It's flood that happens only due to high tides, at least 26 times per year. That's twice a month at least, you know, more or less, a little more. And that floods 10% or more of usable land, not wetlands, usable land. And we evaluated communities that are at risk of this flooding 26 times at least, and at least 10% of usable land along the whole coast of the lower 48. And as communities, we call them, they are census county subdivisions. So if I talk about St. Michael's seeing, 18% of inundation. That doesn't mean the town of St. Michael's. Actually, the county subdivision of St. Michael's includes a lot more, as does Chestertown probably, and some other census county subdivisions. Next slide, please. This is how we mapped chronic inundation, and I'm not going to bother you with it much, but basically we got the tide gauge records going back years. We determined what was the level that was surpassed or flooded 26 times per year at least. And then we added those sea level rise projections over maps of land to see where the flood was going to happen. And those maps are from US Geological Survey and NASA. And so it's all data that's available out there. We didn't create any of that. We just used their data. And if anybody is interested in that specifically, I can go more into that later. Next slide. And our results, next slide, please. Our results can be seen in an interactive map too. It's a GIS tool where you, much like a Google map, you go there into the search box and you enter the name of your town or your home address. And it shows the level of inundation that it's going to be seeing. And on the left side, you see today, 2035, 2060, 2080, and 2100. And in blue in that map is the intermediate sea level rise scenario. And in orange, it will be the high sea level rise scenario, which is the trajectory we are on right now. It's the high. We hope to change it. So next slide, please. For the Eastern Shore specifically, we can see that that's 2035 on the intermediate scenario. On the right-hand side is the inundation area in blue. On the left side, those little blocks of different colors are the communities, the census county subdivisions. So you can see that some of them go over the water, some of them, are bigger, but the darker they are, that means the more area is inundated in those communities. So I can give you the link later and you can play with that later. So that's 2035 intermediate scenario. Next, please. Next slide. 2030 high scenario, and it's interesting that 2030 is 5 years earlier than 2035, but with a high sea level rise scenario, it inundates a lot more than the intermediate scenario in 2035. And then next, please, 2045. So the number of communities increases, the area that's inundated increases just up to 2045. And that's, well within a life of a mortgage for a lot of people who are buying properties these days in coastal areas. And next slide, please. Even though the maps may not show much difference, but we'll see some difference in the next slides. This graph gives a much better idea of how inundation progresses through the years. We have the lighter color is 2035 intermediate scenario. That's the base of each one of those bars. The medium blue is 2030 with the high scenario, and the dark blue is 2045 with the high scenario. And you can see the arrow on the left-hand side pointing to 100% of usable land inundated. And you can see that some communities on the Eastern Shore have it in store for them by 2045, if nothing is done and if things are not taken care of, if protections are not, created, if, so you can see some areas there. Crisfield is one of them. Straits, lots of them. Anyway, the Eastern Shore is second only to Louisiana in land loss to sea level rise and number of communities that currently see inundation. Next slide, please. That's Chestertown. So that's Chestertown in 2035 on the intermediate scenario of sea level rise. You can see where the water is going along some creeks and along, and in the town itself, you can see where it goes. Next slide, please. That's 2030, and you can see it kind of creeping up Water Street there, or whatever the name is, And then next slide. if you go back and forth between these two slides, you see how the red can go, there you go. Go back and forth, there you go. See it going up and increasing the area? That's the difference between 2030 and 2015 years of sea level rise, how much it will. And you can go zoom in closer. If you zoom in too much, you can see that you'll see the red disappear. That means that the layer is too close up to be kept. So you zoom back out until you see the red orange color again, and that's the maximum zoom, but it's pretty close. And I looked at the condor right there to the right of the bridge when we get to Chestertown, and it's going to be flooded. So in high tides, so if you park your car on the street and it's flooded in high tides, there's all that scramble to move your cars away from where it's going to get flooded, and you got to put it in higher ground, you got to move. So that condo was very nice, but it came with a slip for a boat and everything, but that one was out of the question. Next slide, please. And Chestertown was not among the localities in that bar graph. You might have noticed if you started looking for Chestertown there, that's because Chestertown never gets 10% of its usable area inundated. But nevertheless, we know all the trouble that high tide flooding can create already and can create in the future if it's not, even if it doesn't cover at least 10% of usable area. Annapolis never gets to 10% of usable area flooded, but look at the trouble there, and every time they have high tides already, and the impacts to tourism and everything. And I'm talking too much. So one thing that I want to highlight is the implication for low-income and minority communities. Many of those communities, the people who are low-income and minority, they may face trouble, not because they live in the areas that flood themselves, but a lot of them work in many of those areas, and their place of work may be kind of shut down because of the flood. They may not get there, the roads may be flooded, they may lose daily wages because of that. So it's something that we really have to think about when we talk about these issues of climate change, is how they impact people differentially, and people who have the resources do not feel it as much as people who have fewer resources. So I always like to bring that up. Next slide, please. We're getting to the end. Yeah. And I've been talking too much. I thought I was going to speak less than 30 minutes, but anyway, what can we do? We can fight for state and federal support, and fight for policies and legislation that will help us prepare, adapt to the changes that are inevitable, reduce emissions to avoid those that are still avoidable, make better, more equitable adaptation choices. That way we'll have a much better chance of addressing the issues and being prepared. And I hate that word also, resilience, because it's used in so many different ways, but in a good way, being resilient to what impacts climate change may bring is a good thing. Next slide. So I say we must talk science. You don't have to be a pain in the ass, speaking science to everybody and be, oh, here she comes again talking about that science of climate change. No, but it's important, when you have a discussion with friends, family, talk with policymakers, talk with your students or colleagues. If the subject comes up, it's a good thing to kind of have the information ready so that you can talk about what needs to be done, where we are, what's at stake. And next slide. Social media, it's the power of social media can and should be harnessed for advocacy. So whenever you can put something on your social media about climate change, about some study that came out, about some impact that was seen, hurricane season, it's always a good thing because people will kind of get intrigued by seeing the same thing over and over again, the power of repetition, that's a good thing. And on a personal level, next slide, please, don't be afraid to do your share. Back in 2000 and I don't remember when, UCS released this book called Cooler, Smarter, which were practical steps for low carbon living. But there are simple things that everybody can do, like shifts in diet, saving water when brushing and showering, less driving, reduce flying, do more composting, cooking smarter, powering your home with renewables, it's all of it helps. People say, oh, it's not going to help if I change one bulb. Well, yeah, people say that, but together there is power, right? If everything adds up. And actually, if every American reduced their emissions, their carbon footprint by 20%, just 20%, it would be like getting rid of 1/3 of our nation's dirty coal plants and replacing them with clean energy sources, which would be an enormous difference to global warming and to emissions. So there are lots of online tools to calculate your carbon footprint. I recommend that you find one. Nature Conservancy has a great one. EPA, Environmental Protection Agency, has another one. They're great examples. So you can just pick one and track your carbon footprint and see where you can reduce it by 20%. So just pick one and get to work. And next slide, please. We have nothing to lose. If you do something and make the earth better and make everything better, you know, we really, it's a good thing for everybody. So thank you everybody for listening for me for so long. God, I talked a lot. I'm done. The day is done.
This is when you can start asking questions. You can unmute yourself and use the chat system that I described earlier.
I think
Carl Gallegos had a question.
yeah,
Can you
Janet-
unmute yourself, Carl, and ask your question?
Yeah, I asked the effect of climate change on trees and other vegetation and animals as well. Trees, for example, there are more diseases, more insect infestations occurring. Animals, for instance, the Canada geese, these past several years, the size of the flocks coming in the wintertime has decreased significantly. What are other changes that you see coming in that nature?
I see the same changes, only more of them, an increase in number and getting worse. So right now, as you mentioned, we are seeing lots of insect infestations are getting much worse, like in pine trees and a lot of important trees in a lot of places, particularly in the Pacific Northwest. That's because winters are getting warmer. And because without the very cold winters, those insects are not killed over the winter. So they manage to remain alive. And then when it gets warm again, they are not as many of them have died. So they have a much larger number and they create a lot more infestation. So that's one of the problems. Many plants, trees and bushes and flowers and flowering plants, they are also changing their distribution, the geographical distribution. They are moving into places where they haven't been found before. And even though they're plants, they don't move themselves. It's a reflection of the conditions that the seeds find to germinate and grow. They used to be too cold for a seed to germinate and grow in a certain area because, you know, it was not developed, it was not used to it in the sense of, you know, evolutionary sense, you know, for millions of years, or thousands of years, it stayed in a certain climate. And now the climate in other areas is similar to that. So it's moving into different areas. Animals, butterflies have been disappearing. Lots of species of butterflies have been disappearing. Lots of species of birds are showing up in areas and disappearing from other areas. So the main issue here is the change in range, the change in abundance and density, the change in geographic distribution, not geographic, I already said range, the change in interactions. Many animals depend on plants or other animals that used to be together, but now because of climate change and global warming, they are distancing themselves. So this used to come up in March, and this one that ate it used to come up in March. This one is sensitive to global warming, so it's coming up earlier. So when this one comes out, there's no more of this one for it to eat. so this one dies. So there's all these things that are very complex and are being teased out by scientists, lots of studies. But diversity is one of the things of plants and animals that is expecting to decrease significantly with every degree of warming. I hope I answered your question.
Yes, thank you.
So just to remind people, you don't need to write out your question. You can just put the little asterisk, and then this is the way that we decided to do it. And then I will ask you to unmute yourself and say your question. So Tim, you want to just ask your question?
I saw Sue up there, Jan. The first asterisk is Sue.
Oh, Sue.
I'm sorry. You're supposed to monitor it, but I looked at it. Sorry.
Sue Calloway, did you?
Yes. Hi, Astrid. First, I have to thank you for saving Jan's life. We really like her.
But I did.
Yes, we're glad she's still here. My question, I think, has to do with, I feel like every time this conversation begins, and there are people that have commercial industry in mind when they take part in this conversation, there's always a question of expense to the industries, to the companies that are involved. And that's, I know, a big factor for them in changing over to something more environmentally friendly. Is there, what does that look like from your perspective in terms of their costs and their willingness to change?
It looks great. So it looks really great. It used to be that solar panels were super expensive and hard to find and hard to install. The costs have gone down precipitously to the point that it's now, available widely, and it's not a huge expense anymore. The main problem with that, storage. That's where research has to focus on better storage for energy. The same for electric vehicles. If you have an electric vehicle, it's still better than having a internal combustion vehicle that burns fossil fuel, because even if you're powering it on the grid that comes from coal power plants, it still has, the emissions is going to diminish. However, it's better that if we get the renewable energy to those power chargers, right, for the electric vehicles. The cost of everything is going down: wind, solar, hydro, everything, all the alternative sources of energy, the cost is going down. And there is a will, there is a desire, there is an appetite from the workers who have been working in the coal industry in particular, and in the oil extraction industry, and who have terrible health problems. There is an appetite from them once they see that they can still earn a living in a different line of work, that they would be willing to do that new line of work. The main matter is governments have to provide the means for training for all these workers. And we're starting to see some of that happening. So, as I said during my presentation, it's going to take a lot of willpower, a lot of change, but it's not impossible, because what we have out there is already good enough to get a good head start on what we need to do. Thank you.
That's great news. Thank you.
Okay. Sorry, Sue, for skipping you. Okay, Tim, you.
Thanks. My question is, how realistic is it to expect countries like China and India to get on board with the significant reduction of emissions of fossil fuels that are going to be required to make this work?
I want to thank you for not mentioning Brazil. I appreciate it. Well, those countries are already putting out some pretty strong renewable energy percentages on their grids, and they have goals for renewable energy in the future. In fact, one of the main fears in the United States in the past few years is that China is going to get ahead of us on renewable energy. So they have a lot of people. They have other sources, like a lot more of Asian countries are eating more meat. And we know that agriculture and meat producing is huge on greenhouse gases, methane in particular. But it is realistic if there is a payoff, right? Ultimately, it all ends up in the pocketbook. So if everybody's doing it, nobody's going to be the one not doing it. On the other hand, for me to do it, there has to be an incentive. And the market incentives are getting there. The people, you know, people want it. People are clamoring for changes. A lot of organizations, a lot of companies are already disclosing financial risk. A lot of companies, universities, and businesses are divesting their investments from the fossil fuel, from the oil companies, from the, you know, disclosing what they call climate risks. So there is hope. I'm always hopeful, but realistically, it's not something that's going to happen in the next 10 years, right? We know that. But on the other hand, the oil business, the fossil fuel companies, they know that they have a limited amount of time ahead of them to continue to explore oil and to distribute oil-based products. They know it's coming. That's why they are trying to advertise on the TV that they're investing in wind and solar and all kinds of good things. They're not there yet. There's still a lot of lying out there by their part. But they're not stupid, right? They are realizing that things are going to have to change or break.
Okay, the next person is Mike Droge.
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 Can you hear me?
Yep.
Yes.
Okay. Well, my question is similar. First off, when did the Paris Accords start? Just out of curiosity, and has China signed on to those Paris Accords?
Yes, China signed on, and the Paris Agreement, we like to call it agreement.
Oh, agreement. I'm sorry.
Yeah. No. A lot of people, including the media, call it accord. It's just something that we like to call it Paris Agreement, but you know, accord is perfectly fine. The Paris Agreement was in 2014,
Okay.
or 15, and it came only coming into full. What's the word you said? 2020, just last year was when they got together and they revised their what they called national contributions, national intended contributions for their reductions, their emissions reductions, and they have to revise that every few years. And right now, what countries have pledged is not enough to keep us below 2 degrees. So everybody's pressuring everybody to kind of increase their ambition, as we call it, in terms of emissions reductions. And I think there are only 2 countries that didn't sign, that are out of the Paris. Well, US is back. I think Australia is out. Venezuela is out. Something like that. Just 2 or 3 countries are not in the report. That's
Brazil.
The reason I asked is I traveled the world pretty extensively for my employer, and from 2010 until 2015, I went to China like 10 times, and I went to Brazil, but Brazil wasn't by far the worst air I ever saw was in China, and that's why I was asking it, because I'm hoping they've cleaned it up since then, because
yeah,
like I say, it's been 5-6 years since I've been back there, but it was terrible. Yeah. Oh, and on a little aside, I think I heard earlier that you're looking for some place in Kent County.
Are you a real estate agent?
I am not, but I live in, unless you're committed to the Chester River, I live up on the Sassafras River in a little community called Kentmore Park, and there are a couple houses up here for sale that you might want to take a look at.
I'm going to look into it.
And you wouldn't be able to get a slip, but you'd be able to get a mooring. We have community moorings, and it's a waterfront community on the Sassafras.
Yeah, we are looking at places that are at least 20 feet up from the water.
Oh, sure.
Yeah.
Yeah, I'm probably 20, 30 feet up at least from the water.
I'm going to look into it.
Okay.
Thanks, Mike.
Thank you. And a very nice presentation.
Thank you so much. Appreciate it.
Thank you, Mike. I think this one is Hanson.
Yes. Unfortunately, somehow my name doesn't show up.
Your number.
Question. I have two questions, Astrid. One is, there's a blanket of CO2 over the world. Is that blanket evenly spread, or is it got concentrations?
It's not evenly spread. It varies. And it's not the concentration so much as the winds and the things that come from other processes, like the aerosols that I mentioned, the clouds. So the patterns of circulation around the globe move those, carbon dioxide concentrations around quite a bit. So we say that China emits a lot. And because of the patterns of wind and concentration there, they get a lot of that pollution also in those things in the atmosphere right there. But there are areas in Northern Europe and Northern Eurasia where the winds kind of blow a lot of things away. On the other hand, in Greenland, wind blows in and brings what we call black carbon, which is like the soot from burning coal and everything. The prevailing winds bring a lot of that black stuff and puts it on top of the snow. So there is always the circulation. It's never the same. There are certain places that always reach the higher concentration first, and Hawaii is one of the places that they use as a reference.
Well, thank you. My second question is, I'm not a scientist, but is hydrogen a possibility for powering motors and vehicles?
It is. It is. The technology is not completely there yet, but certainly is. And the best part is that powering with hydrogen, the byproduct is water for the most part, and a lot of the things that they have done so far that I know of. I have to confess I don't follow it closely, but it's certainly a possibility. Anything that we can think of and do research on and try to invent that in some way does not release more carbon in the process of making it and the process of using it is good.
Thank you. And thank you for your wonderful lecture.
Thank you.
Wayne Bell had a question.
I have a question. Oh, I don't know how to get into the queue, but I have a couple of questions.
Go ahead.
Okay.
I'm on mute there.
Yeah,
Thanks a lot. I wish I could say I enjoyed your talk, but it's obviously something that's of serious concern to us all, and it was really, really informative. I'm concerned on a more broader aspect of not just climate change itself, but the politics involved. And I guess it's a kind of a two-part question. First of all, what's your feeling about the growing, what I will call nationalism, which seems to be a global phenomenon right now, and how that might affect our ability to resolve some of the issues that are clearly global in nature, climate change. And the second part is basically, is there any hope that climate change might in fact drive more international collaboration to resolve these problems?
So the answer to your second question is yes. There are good signs of international collaboration to tackle the problem. There is always the ones that do not want to be involved and want to do things by themselves and do not see things as being fair or not being, such and such did more, why do I have to pay? Things like that. But overall, the spirit of collaboration is alive and well internationally. So that's a good thing because it's necessary, it's essential. In terms of your first question, the nationalism around the world, as you mentioned, is on the increase. There are these feelings of nationalism and a lot of people wanting to go to systems and things that were in the past for a lot of them, the way things were, how much better things were back then, and the thoughts and everything. The main thing in that is the values of people, right? So if people have values that are against the protection of the earth and the protection of the environment, the protection of life, then we're doomed. But for the most part, even the most radical person has that in common, that they want clean air, they want clean water, and they want some environment for them to enjoy, be it the beach, the forest, to hunt, to swim, something, right? So one of the things that we do is try to appeal to those common values and those common interests of people to try to bring them together on a path that is the best path to keep those things that they value alive. And that's independent from religion, that's independent from politics, that's independent from party, from how you think about anything, what you eat, if you're a vegetarian or you are a meatitarian, you know, it doesn't matter, because we try to find those common values. So I think that the main impact of nationalism rebirth has been so far the change in governments and the people who have been elected, and the way that those elected people in turn kind of bring things back, not only to the good things that were back then, but also the bad things that existed back then. No protections for water, no protections for the air, no protection for the people. So it's a very complex, you know, as you know, very complex situation. But because of natural cycles in politics, particularly, and you know, things pass, things take turns, right? So we're seeing now things kind of moving in a different direction with all the demonstrations about race, the demonstrations about, you know, impacts on religion, the demonstrations about women's rights and all these things. So I think, you know, I think we do what we can and we hope for the best, but we cannot just sit back and wait. I hope I answered.
Thank you for that really hopeful answer. I appreciate it.
I'm always hopeful, Wayne.
Astrid, I had a couple questions about the pandemic, and what the first was just what you think the effect of less travel and air travel and all of that business might have had. And secondly, I read something about that there has been an effect of beneficial in that way, but that the wildfires in California sort of offset that. And I wonder if you could talk about that, both those things.
Certainly, thanks. So globally, there has been a deep decrease in emissions. Not the amount in the air, but in the emissions amount, right? Because of the, as you said, the travel was deeply reduced, urban transportation was deeply reduced, all of that. So that had a great impact. And last year, we saw some of the lowest levels of emissions globally ever since since we started going up. However, this past month already, the emissions are back up and beyond where they were. So it's not something that's gonna stay unless people sit down with policymakers and decide about some changes that need to be made along the lines of what we can do to reduce emissions. The California wildfires were terrible, not only because of the carbon dioxide and you know everything that was being pumped into the atmosphere, but also because of the amount of pollution and smoke and health problems that it created. But that was very localized, right? So even though we got the plume of the burning here on the East Coast, you remember that, we had a couple of days that were kind of hazy, and that was the smoke coming all the way from the West Coast, which is amazing, which kind of brings it back to Hanson's question about the, you know, the concentrations and how things circulate around the globe. So there's a lot of localized impact, and yes, the California impact was very, the wildfires was very intense, but the emissions unfortunately are back up. So we saw that emissions can go down significantly, and hopefully we can find a way that we don't need a pandemic to do that, right? And find better ways to do that. So I don't have much more of an answer to your question. Sorry, Jen.
No, that's helpful. Thank you. I think we're out of questions. Unless anybody else has any. I see somebody raising their hand there.
Oh yeah, somebody who didn't know how to.
Yeah, I didn't know how to get into the queue.
Okay, well, go ahead.
Okay. The extreme scenario that you mentioned, 8 feet of sea level rise by 2100. I've seen scenarios that are more extreme than that. Like much more of the continental ice, like on Greenland and Antarctica melts. There's a lot more water there that are raised at sea level, maybe more than 100 feet, as it was millions of years ago. There were warm periods where the sea level was more than 100 feet higher. So is there a point of no return where the runaway greenhouse, we wouldn't be able to do anything no matter what we tried?
Yes, there is. We call those tipping points. And once a tipping point is reached, there is no turning around. So we don't know when the tipping point will happen for sea level rise and for the melting of the Antarctic ice sheet and of Greenland ice sheet and the Arctic, because we don't know how much emissions we're going to keep pumping into the atmosphere. So if we pump a lot and really fast, what we are seeing in terms of melting can materialize faster, and we can have a lot more melting, eventually leading to a collapse. And as you mentioned, I think the Greenland, if it completely melts, the Arctic land-based ice, it's like 20 feet of sea level rise that will be added. And if Antarctica goes, it's 100 feet or something like that. So we want to try to avoid those. And the thing is, research is showing that because the ocean is getting warmer, also a lot of the warm water under the Antarctic ice sheet is melting it from underneath and making it more prone to breaking pieces that eventually go into the ocean and melt. So every year, the refreeze of ice is a smaller and smaller amount. You know, even though there is more snowfall in some areas, but that doesn't translate into the ice continuing. So this is kind of a downer. Yeah, it is. But the good part is what I said in the beginning. We don't know if that will happen or when that will happen, because it depends on the amount of emissions. That's why reducing emissions, no matter what, is the number one thing that we can do to avoid the known impacts and the unknown impacts.
Yeah, my only other question is, a lot of the CO2 that we're putting into the atmosphere eventually winds up in the ocean. So we're not only warming the planet, we're acidifying the ocean. And that affects a lot of creatures. I saw on one of your slides the reference to the coral reefs, but it really affects a lot of creatures at the bottom of the food chain.
Yeah, a lot of the mollusks, a lot of the oysters, a lot of the shells, all of that is affected by that excess carbon dioxide into the ocean with the acidification, and the shells become softer, become lower quality, so they cannot survive. It's a big impact. Yes.
Yeah, it's not as visible to most of us as the above ocean.
Yeah, but it will be visible. Hopefully not, but if it continues, eventually it will be visible in fisheries, you know, in the oyster business, in the, you know, New England, you know, the clams, all these things are eventually going to be impacted if acidification keeps going up. And then the cascading effects of all, you know, there's always this thing, the cascading effect, that we don't really know. We hypothesize, if this happens, then this happens. If that happens, then that, but we don't really know what exactly is going to be the path of those interactions that I mentioned earlier that are so important for a lot of living organisms to keep thriving.
I wanted to thank you for your presentation. That's the end of my questions.
Thank you. Thank you so much.
It was great, really great.
Thank you. I hope I was clear.
Thank you, Astrid, for this wonderful talk. And I think it's time to close. And I really appreciate your remarks. And thanks to everybody who listened. So we're signing off.
Thanks, everybody.
Astrid.
Great. I hope to meet you in person sometime.
Yes,
Same here. Thanks.
thank you.
Bye.
Bye.